This is a video about quadratic applications. So as you can see here, you're given a graph of a parabola that is facing down. It opens down and has a maximum value or a vertex. So we're going to start exploring some of this stuff. You can see our x-axis is time in seconds and our y-axis is height in feet. So in this scenario, we have a little toy rocket was launched from the roof of a building. The height of the rocket h can be described by the equation h equals negative 16t squared plus 40t plus 35. Now, as you saw in the last video, you can put things into Desmos and it will graph it for you. So if I went into Desmos, I can change this. It will allow you to put H and T, or you can, apply the X and Y's. It's fine either way. So looking at this, we're going to start answering the questions below. So the first question is approximately how many seconds was this rocket in the air? Well, as you can see, from time 0 seconds right here, we have 0 seconds, and it was in the air until it hit the ground here. So I would say it was in the air for 3.2 seconds, approximately 3.25. Not quite halfway, so I would say probably 3.2 would be a little bit more accurate. All right, answer the next question. About how many seconds after launch did the rocket reach its maximum height? Well, the rocket got launched here and reached its maximum height at about between 1 and 1.5, so 1.25 seconds would be between those two. So at 1.25 seconds, it reached its maximum height. Next question. At t equals 2 seconds, what was the rocket, or was the rocket going up or down? So in 2 seconds, we're looking at time. So in 2 seconds, I'm going to go up here. So what's happening with this parabola? Well, if the rocket's traveling, it would travel up and then coming back down. So here at 2 seconds, we would say it was going down. During which half-second interval was the rocket traveling the slowest? Okay, let's start talking about, looking at the line portions of this graph. So here you can see it's pretty extreme, and here it's a pretty decent slope as well. Where is this has the least slope? Because it's going to go the slowest where it's the least slope. So overall, I would say between here and here is where it's going the slowest. It looks more like a straight line from this point to this point. So during this area we want only a half-second interval. So I would say between 1.25 and whatever is going to be in between here. So from here to here, we divide half divided by 4. That's going to be a 0.125. So 1.125 and 1.375. So I would say, that's where it's going to have the half-second interval that it would be the slowest. Really, it's going the slowest right here at the maximum. All right. Let's go on to the next question. How tall was the building from which the rocket was launched? And we recall, it got launched at the roof of a building. So hence why at 0 seconds, it starts right here. So it really did not go backwards in time because that's just not even possible. So here's where it was launched. So at 0 seconds, it was at 35 feet high. So how tall was the building? 35 feet. What was the maximum height the rocket reached? Well, its maximum height is its vertex right here. We already talked that that is 1.25 seconds to get to the maximum height. And the maximum height, if we look at the height, was at 60 feet. Approximately how much height did the rocket lose between 2 and 3 seconds? Well, let's kind of start looking at this. So at 2 seconds, approximately what height are we looking at here? I would say we're at what, 50? I'm writing with my mouse, so looks more like kindergarten writing. And then at 3 seconds, we are about right here, which I would say is 10 feet. So if we're looking at this, well, what's the, how much did it lose? Well, from 50 feet to 10 feet, 50 minus 10 would be 40 feet. And the last question is, at what times was the rocket 45 feet high? Well, 45 feet here, as you can see, it hits it in two different places. It hits it right here as well as right here because it went up and it hit 45 feet, and as it was coming back down, it hit 45 feet again. So what were the times? Well, let's look at them. This one was about between 0 and zero point 0.5, so I would say 0.25 seconds. This time is in seconds. And then here we're looking between 2 and 2.5, so 2.25 seconds. So those were the two time periods that the rocket hit 45 feet. Go ahead and see if you can match some graphs to some equations along and put some things together.